All right, everyone. If you're watching this video, you have the study guide in front of you for the Unit 6 test on Pythagorean Theorem, geometry, distance formula, all that good stuff. And you might want a little bit of support because I got to tell you, this test is going to be tough. So here we go. I made up some very similar questions to the test. You're going to see them on the left. They're also very similar to the ones on the study guide. So by watching this, you're going to be prepared to do the study guide or the practice test. And then by doing the practice test and getting it checked, you'll be ready for the exam. So let's go ahead and take a look. On the right, I have my calculator ready to go. And we're going to begin with question number 1. Calculate the length of the missing side. Round to the nearest tenth. Simple enough. So I see it's a right triangle, so right away I know that I'm going to be using the Pythagorean Theorem. I'll get that ready. I recognize that across from the 90-degree angle is always the longest side. So my longest side in this case is 14. That makes 9, either A or B. So I'll just put it in the A spot. And I'll leave B, B. And everything gets squared and added and equals. And now I'm going to evaluate 9 times 9 is 81, plus B squared is 14 squared. I'll use my calculator for this one. And I get 196. And we'll do a minus 81. And let's see, 196 minus 81, 115. I'm running out of space, so I'm going to move over here. I'm going to get B squared equals 115. And I take the square root at the end, and I take the square root of 115 and 10.7. Simple enough. Okay, so that's the procedure for finding any missing side in a right triangle. That's it. Just decide which side is which, A, B, or C. Place them in the equation, and then just solve your equation. Moving on to number 2. Find the distance between A and B. Now, in a problem like this one, we didn't do a lot of these, so I'm a little bit nervous for you. But here's the thinking. I've got a lot of, quite literally, a lot of straight sides here, and even left and right. You know, we'll call those straight. That's not a very good descriptor, but let's go ahead and call those straight sides. But I have one diagonal pretty clearly. Well, what you want to do is identify your diagonal, which is easy enough to do, and then I want you to make a right triangle out of that diagonal. So what I think that means is come over and come down. And I'm using a highlighter tool here to kind of let us see through it. But this right here would be our 90-degree corner. Now, the longest side in a right triangle is always across from the 90-degree corner. So this is side C. So this is going to be side A, and this is going to be side B. And we just need to figure out A and B, and then we can calculate C. So Pythagorean theorem again, A squared plus B squared equals C squared. I'm going to get rid of, well, let's see what we need to get rid of. Things I know. I know that this side, I'm going to use pink for this so it stands out a little more. I know this side right here is side A in my equation, right? That's going to be that. However, I have a total length of 20, and that doesn't seem to help me. That's too long. However, I also know that this side over here is 14. And if I imagine moving that side I just highlighted kind of over here, if I remove that from the 20, what remains behind, look at that, what remains behind is from here to here. That's side A. So I'm going to go ahead and do 20 minus 14. 20 minus 14 is 6. So there we go. All right, I have my A value to start with. Now, in a similar manner, let's declutter this a little bit. In a similar manner, I need to know the distance from, well, here to here. Okay, let's do that again. Here to here. And I have part of that distance, 10, but I need this part, all right? And I don't know what this part is yet. Well, if we don't know that, we can't really complete the problem. So I'm going to tell you that I left this one undone on purpose because what you're going to see in these problems is some sort of a total, right? When you see a total, let's imagine the total is 25, okay, 25 units. Here's what I observe. This side is 12. This side, as we've already established, is the 10. And this side is the missing side. But I know that if I put the 3 of them together, it's got to be 25. Well, 12 and 10 together make 22, but I need to make 25. That means this piece has to be 3, and I hope that makes sense. If it does, then look what we have. We have 3 plus 10. So now we know the B side is 3 plus 10 is 13. So watch what I'll do. Grab pink again. B is 13. All right, I've found my two sides. Now it is as simple as Pythagorean Theorem. 6 times 6 is 36. 13 times 13, or 13 squared, is 169. I'm going to add those together. Plus 36. Oops. Let's try that again. 169 plus 36. These buttons are teeny tiny. So I get 205 equals c squared. And we're going to go ahead and do the square root of 205 and 14.3. There we go, done. All right. So we had to work on finding the sides, or what we call the legs, but otherwise pretty simple. Now, number 3, I'm not going to actually do the whole way, but I am going to mention it because I think it's going to throw a few of you off, and I don't want that to happen. This is actually the same image as is what's on the practice quiz. So same deal. You're trying to find the height of the balloon. I'm going to highlight this thing. I'm trying to figure this out. Okay, that's the objective in this problem. Well, here's what I have. I have a diagonal, and if I use the diagonal the way I've used it before, I section it off, I make my right triangle out of that. Okay, there we go. There's my right angle. Well, I have my hypotenuse, right? I have my side C is 50. And look at the bottom here. I have 25. So it's kind of easy, right? So if that's 25 and the other side is 50, then what I can figure out pretty easily is the distance from the balloon to the bottom of the triangle is going to be my Pythagorean theorem, right? I'm going to calculate that 50 squared. I'm not going to do it right now because that's for you, but I'm going to calculate that and I'm going to get a number. It should be easy enough to get. And then when you get that number, we still don't have this part accounted for, right? That's part that's below the triangle. But look over here, right? I'm trying to be tricky, but I'm not that tricky, all right? I tell you how high that is. You can then transfer that over, combine it with the number you've already come up with, and that will be your answer. So I'm a little cryptic on this one, but I wanted to push you in the right direction. Now, something I don't want to be cryptic on is number 4, or a style like number 4, where I see a shape with a triangle or a diagonal line through the middle, and it starts to ask questions like, what's the perimeter of? Now, the perimeter, let's be super clear, B, C, D. Look, B, C, D. I'm going to go from B to C to D. So that means this triangle, right? That's what it's asking about. What's the perimeter of that triangle? So in that case, I'm going to go ahead and add up those 3 sides. I have the 6, I have the 10, and I don't have the diagonal. So I guess I'm going to have to use Pythagorean Theorem. No surprise there. That's side C because it's across from the 90-degree angle. So 6 squared plus 10 squared equals C squared. We can do this part in our head. 36 plus 100 is C squared. That's 136 equals C squared. And the square root of 136 is 11.7. Now, because I like writing on the drawing, I'm going to go ahead and put 11.7 on there. I think that's a good idea to kind of keep things straight. And then 6 plus 10 plus 11.7. 6 plus 10 plus 11.7. Oops, I have the answer in there. 6 plus 10 plus 11.7 is 27.7. All right, so in my example, 27.7 units. Next question, next bullet. What is the perimeter of oh, this isn't written well. It's supposed to say rectangle ABCD. I left the A off of there, so my apologies. But it's supposed to be that, which means we're going around from A to B to C to D, and it's the perimeter of the whole thing because it says rectangle. So we just have to add up all the sides. Important here that you understand if this side's 10, which it says it is, so is this. So 10 and 10 make 20. If this is 6, so is this. 6 and 6 make 12, and 20 plus 12 is, 32. All right, now at this point, we can do some comparisons if that's what it wants. Third bullet says how many more, as soon as I see how many more, I'm going to be probably subtracting something. I'm going to compare them. Is the perimeter of ABCD, that's 32, compared to the perimeter of BCD, that's this one. So I'm just going to find out how much one is more than the other using subtraction. And here we go. 4.3 is it. All right, the trick on these is simply identifying what they're asking for. Let's immediately move on. Number 5 on mine says find the distance between these points. Now, I'm not going to do both of them. In fact, I might not do them the whole way either. I think you just need to know what you're looking at. So the distance between the two black dots, you can see that they're kind of offset. I'm just going to connect them. That's my diagonal. So just like I did with the blue highlighter earlier, I'm going to go ahead and make my right triangle right on the grid. I'm going to count the spaces, 1, 2. So this side is 2 long. 1, 2, 3, 4, 5. So this side is 5 long. And then I'm going to use the Pythagorean theorem, right? Let's do this one out. So 2 squared plus 5 squared equals c squared. C is the diagonal. I don't know what that is. 2 squared is 4, 5 squared is 25, and 4 plus 25 is 29. I'm going to square root both sides. For that, I'll use my calculator. Square root of 29 is 5.4, so 5.4, right? The two dots, you would do them the same way. Your drawings might overlap a little bit, but ultimately that's pretty straightforward. Number 6, moving on. In number 6, it's the same exact question. In fact, if the numbers are small enough, and these might be small enough for some of your whiteboards, you can actually do it the same way I just did the black dots. You just make a dot here, you make a dot here, you draw your diagonal, make your lines to make your triangle, and then you just count. There is going to be a different technique, though, I'm going to teach in class. It's kind of hard to know who's seen what with me not being there, but I'm going to go ahead and say the x value here and the x value here between 6 and -2. 6 minus -2. Those numbers are 8 digits apart. The difference between -4 and -10, -4 minus -10. The difference between those is, oh, I didn't hit the negative. -4 minus -10. I saw that 14 and it threw me off because the answer should be 6. Those numbers should always be positive, and those numbers are your A and your B. So we go ahead and plug those into Pythagorean theorem. A squared plus B squared equals C squared. 8 and 6 and C, squared, squared, squared. Add the first two to get the third. 64, 36, C squared. I've had the advantage of doing this one before. I know these are 100, and I bet you all know that the square root of 100 is 10, so that's the correct answer. Right? That's the procedure. Your numbers might be bigger, or they might even be a lot bigger, but the concept is shown on the right-hand side where you just subtract to figure out the difference between them, right? This is the difference between the first two. This is the difference between the second two. All right, I think we're almost done here. The last piece is what's called the converse of the Pythagorean theorem. It says look at the triangle, determine if it is or it is not a right triangle. Now, I'm going to go ahead and say if we look at this, it doesn't look like a right triangle, but you should never, ever, ever trust my drawings for sure, because they're just not that good, and you really shouldn't trust anybody else's either. What we don't see in any of the corners is the 90-degree mark. That doesn't mean it's not a right triangle. It means it probably isn't a right triangle, but we have to go ahead and do our numbers. Now, here's the thing. If you're really good with your numbers, you might know which one of these is biggest, right? So we're still using a squared plus b squared equals c squared. Ultimately, that's the equation we use for this entire unit. Well, the issue is I don't know what a, b, and c are, because while I know what 8 is and I know what 7 is, I don't actually know what the square root of 101 is. So it might not be a bad idea to go ahead and decide using the square root of 101. You might want to get an estimate of 10.0. So though it's not 10, it does give me this is the biggest. So with a quick little calculator, we can identify which one's the biggest. And the biggest one is always side C. So I'm going to zoom in here a little bit. So 8 and 7 are my two smalls, and the square root of 101 is side C. Notice how I'm not using my calculator. I'm just using the square root of 101. Everything gets squared. Add the first two to get the third. Now, 8 squared equals 64. 7 squared equals 49. And 64 plus 49 is 113. All right. On the other side, I have the square root of 101. So watch this. The square root of 101. Oh, I have that answer in there again. Square root of 101. I'm going to press enter, and then I'm going to press the squared button. I wish I could show you what button I'm just going to push. It is above the button that says log. It's diagonal up and left of the number 7. I'm going to hit the squared button and watch what happens. I get 101. All right, now when I bring this 101 down here, see how these do not equal? In other contexts, we would say no solution. In this context, we would say not a right triangle. All right, that means that the Pythagorean theorem does not work. And if it doesn't work because it's not a right triangle. That's the rule. And we're going to do it down here again. The only difference here is we're going to do it without a picture. Number 8, a triangle has side lengths of 6.3, 8, and 3. The advantage here is that we can look and see which side is which. This is clearly the biggest side. So in my a squared plus b squared equals c squared, 8 is going to go in the c spot, and the other two numbers are going to go in a and b. It doesn't really matter where they go, so 6.3 can be a and 3 can be b, as long as the longest side, this is the biggest side, as long as the biggest side is always in the c spot. All right, so here we go. Square, square, square. Add the first two to get the third. Let's use our calculator. 6.3 squared, 39.69. 3 squared is 9. 8 squared is 8 times 8 is 64. And I'm going to go, I'll do it, but I already know 39 and 9 isn't going to be 64 plus 9. It's not even close. So 48.69, is it equal to 64? Heck no, it's not equal to, so it's not a right triangle. If they ever would work out, then it would be a right triangle, but I had 2 examples in a row, neither one of them worked. The 113 and 101, 48.69 and 64. And that is it. Kind of a long video, but you should be prepared to take on the practice quiz and then be prepared to take on the unit exam to follow. Good luck.